Hey YouTube, it's JP Dillon. Today we're looking at a early 1980s Pioneer Model sx-3500. This was one of the smallest in the line that still had the fluorescent power display, and it's just been complained of poor performance, channels cutting out, etc. So we're going to take a quick look at it. Somebody had the bass cranked all the way up. I'm sure that sounded lovely. So let's go ahead and turn it on here. And there's our fluoroscan display. And we're currently on auxiliary. So we've got our scope hooked up. Let's take a look at the output. And as we can see, there's our touchy volume control for sure. Even the slightest amount of movement causes that left channel to disappear, and right's not great either. Balance control really isn't functional. There's one extreme, and there's another extreme there. Tone control is very touchy. So that's pretty much par for the course of something like this. Let's switch over to FM and see if we can... Now let's hook up my signal generator to the antenna and see if we can get some semblance of reception here. Let's turn the muting off. Alright, so the tuning condenser is obviously very touchy because all I have to do is just slightly move it and it's just off center. There's our nice fluorescent display there everyone loves. But we are receiving, which is good. It's not at the right spot. My generator is at 98.5. That's at 98.2. So the tuner needs some work too. Cheap tuners do not have low-pass filters in them, so what you're seeing there is the pilot signal, the 19 kilohertz riding on top of the 1 kilohertz. If I turn the pilot signal off, you can see it cleans up. We also, let's turn mono back on so that you can see there when I switch to the right channel only, the left channel's got that pilot noise there. So not great, but most people ain't going to hear 19K, so they figured that was not a big deal. Also, the sensitivity on this really sucks. Just awful. So we need to look at that too. And let's just briefly see if I hook up the phono. So I do have the turntable input working. Proper RIAA curve. Higher frequency, lower the amplitude. Lower the frequency, higher the amplitude. That's just how they equalize it so that you don't have intermodulation run over. One groove modulates into another because it's too big. Okay, so let's get this thing apart and see what we need to do to clean all the pots and switches. Alright, well here's what it looks like on the inside. Pretty simple. It's got the infamous batwing transistors here. I think it's a 2SD588. Yes, let's make it as bright as the sun. I'm trying to zoom in here, but it apparently does not want to cooperate with me today. Up 2SD586. Can't read that guy. Yeah. Anyways, these are tricky to find. Last time we saw these was in a SA9500 Mark II. It's a little bit dirty in here. Not terrible. By this time they were really relying on integrated circuits, although these ones use actual Hitachi ones instead of the famous Pioneer PA prefix devices. Oh, there's one. 3001A, that's your FM IC. And the 1156 is your multiplex, I believe. Phono preamp is pretty discreet. It's all tucked in over here, I think. And then we have your fluorescent driver display there. Your enormous power supply capacitors. Yes, sarcasm. And the lamps, I'll probably change out. There's only two of them in here, unless the third one... Nope, there's just two. You'd think there'd be 3, but there's no wiring for 3. You just have wiring for 2. Okay, and then I think this lamp was out too when we checked it. And the lamps are probably not visible from here. Yeah, I'm gonna make everyone dizzy this way. So, to clean the pots and switches on this, an extension straw is needed so that we can get down in here. Kind of hard to see. The input selector is probably the easiest to get to. The rest of them is tucked underneath this board, which is why you have the extension straw. And if we go down into here, you can kind of sort of see what I'm talking about. Switches down in there, pots down in there. And I've cleaned my lens a bunch of times, so I don't know why there's this haze there. Maybe there's a crack in it. Oh well, it's going to be time for a new camera soon anyways. Okay, so to appease the dust phobics, we're going to clean the dust off of here. I don't think this is a particularly powerful machine. I think it's maybe 30 watts. Might be more. I don't remember. And this is your only protection against DC failure. Those are output fuses there, so if you lose a channel, check to make sure that those aren't popped. Yeah, just gonna dust this out as best possible here. And then let me set the camera up and we'll get the extension straw and start cleaning switches. Alright, so here we are. Got the camera on its mount. I can turn that off now. You can get a little bit better view. And we're just going to come back in here with our CRC and just kind of hose the line control somewhat. Rotate it a bunch. And we'll go to the input selector, apply a generous amount here. Sometimes you have to use deoxit on the selector switch. I'm hesitant to use deoxit these days because I think they changed the formulation. It seems to be more aggressive on plastics than it used to be, but that's just my observation. And then we'll come over here to the balance control. Nice thing about CRC QD is that it's quick drying, so you have to be quick with the cleaning, but it also doesn't leave a residue, which is nice. So that's our balance control. Then we'll come in here to our tone controls. Work them a bunch. I know this is like super exciting. And then finally down at the bottom here, we have our base control. I'll tilt this guy up so I can get to it a little better. Okay. Let me reposition the camera. And we'll come down here. And I'm going to get a little bit of contact cleaner as I can into these speaker selector switches. And work them a bunch. Now I'm going to tell you something about this generation and the little black switches that are used as the push button switches. Let me get the camera here and I'll show you. these generation of switches right here have plastic failure. The latch is made of plastic, and if you use deoxit on these, the plastic will get soft and they will stop latching. And in fact, you'll see many of these generations of Pioneers with these switches where the plastic latch has failed and the buttons don't stay in anymore, and you have to replace the switch. There is no cure for this other than to find another switch. So I only use CRC on these switches. I don't use neutral because I've noted that the oil sometimes can make the thing sticky. I don't use deoxit because it softens the plastic and makes for a failure. Use only CRC on switches that you see on these Pioneers like this, or any gear from this vintage that has these type of switches. So that's your PSA for the day. And I just go in right at the vent port, which is the bigger of the two holes there. Just, you know, get your extension straw in there and spritz them inside of there and then work it. So I'm going to finish cleaning these and then we'll work on cleaning the tuner assembly. Okay, so now that we've dealt with that problem, let me show you about cleaning the tuner on these. Now, this is the only thing you will ever want to clean this tuner assembly with. Anything else will leave residues and oils that will detune the tuning condenser and make it impossible to get a good alignment. Buy some of this. And then what you want to do is come down here and see these rotor points here. They're made of brass. They corrode. There's a total of 4 of them. There's one on the very far side here you can't see. There's this one, and this one. And what you want to do is spray and then rotate your tuner back and forth vigorously to clean the contacts. Now the reason why you use the QD, again, because it doesn't leave residues and it's not going to cause your tuner to detune out of alignment. Now we have to do the alignment on this one anyways, but most of you, I guess, don't have really much experience with aligning an FM radio, so don't mess it up if you don't have to. Using anything else with oils, protectants, or residues will cause the tuner to detune, and then you won't be able to get an alignment on it. Every time you turn it on, it will be different. So, now that we've done that, we're going to turn it back on and select our FM and see. Let's turn the muting off. So right now, it's reading high. It's 98.7. Now let me get a can of compressed air and we'll blow it off and you'll see it change. Because right now, it's in tune. Now watch what happens when I blast the remaining stuff out. Oh look, it's out of tune. And then we bring it back to 98.2 again. And so that's the final where we were before. So that's how we know we got all the stuff out. But yeah, the residues will leave you detuned and not able to do a full alignment. So the quick drying stuff is where it's at. But now I can tune the tuner and we can see that it's smooth throughout its entire range. It's no more twitchy. The center of channel meter is precise. So we now know it's clean. We're going to do a really quick touch-up alignment, and I'll show you how to do that with these. Probably the easiest thing to do. Let's get a really good antenna on it first. Okay, so I've got the generator hooked up directly to the tuner. Now, what we're going to do is we're going to take an IF sample off the second filter, which is right there, the left-hand terminal. And I'm going to get my scope, and I'm going to place it on the left-hand terminal. And when I do that, you're going to see there on the bottom, that's our RF information. Okay? That's your RF. That's your pattern. And if I come over here and I turn the generator up, excuse me, I'm doing this one-handed, more signal equals fatter. All right? So I'm going to turn that back down. And you're going to start off with a smaller signal so that you can tune it. Let me remount the camera. Now this is going to be really tricky to display because I'm kind of in the way of everything. We're going to try to keep the scope in view, and we're going to try to keep the tuning condenser in view while we adjust the RF trimmers here and here, and watch the pattern on the scope as it gets thicker and thinner. I'm going to see if I can use my mini hook to get on to the ceramic filter here. I don't know if I can. I don't think it's... Yeah, I got enough space here. Yes, no. Alright, so you can see the fat pattern there, which we're going to turn down the generator until that pattern gets really skinny. And then what I'm going to do is I'm going to adjust the antenna trimmer first. And again, we're at the middle of the band. And I'm going to peak the trimmer for the widest pattern on that scope there. So you see in one direction it gets thinner, one direction it gets fatter. And we're just going to peak it out. And now we're going to do the next one over the RF stage. And again, one direction makes it weaker, one makes it stronger. Big difference there. And of course the phone's going to ring right now, even though I'm technically not open today. Let me grab that real quick. Alright, so we're good there with the RF input. There's ample amount, and the tweak definitely helped. Now, we're going to switch back over here. And now what I have to do is we have to align our dial pointer. And so right now we need to be right about here. And so when I move it to 98.5, you can see that it says that we're way off tune. So if we go back into the tuner, we see that there's that little ceramic trimmer right there. That's your oscillator. You need a special tool to align it. If you don't have an alignment tool set, don't tweak it with a metal screwdriver. You will break it. And so I'm going to adjust the oscillator until we can center up that center channel meter. And it's very touchy adjustment. And it's pretty close. Yep, I think we're good there. So now it reads proper at 98.5. Okay, so we got all that done. Let's take the bottom off real quick and take a look at the solder. Now, pioneers of this vintage, the soldering isn't very good. And what we look for are darkened areas. Like there's a darkened area that's darker green than the rest. That's an indication of heat, and you want to look around that area because there's a good chance that the solder's corrupt, like that. You see how you have that dark shadowing around the leads coming out? That indicates oxidized and crumbling solder. So these connections here need to be resoldered. And we'll just take a quick look around. Make sure that nothing else needs any attention here. So far it looks pretty good. Also, you want to check at the back where your RCA jacks attach. These guys here look pretty good. If somebody's using monster cables, it will usually cause the pads to rip free from the board and cracks in the housing that hold the jacks. So, monster cables bad, kids. Don't use it if you don't have to. So thankfully, it just looks like this guy right here. This area is really the only area that we need to focus on resoldering. So we're just going to grab our soldering iron, which is hot. And then we'll resolder these couple of connections here, which look kind of shaky. Usually the areas of heat are in the power supply where the regulation occurs, because a lot of heat is dissipated by the regulators themselves. That's especially true on a machine like an SX-780, where they didn't have enough heat sinking for the regulators, and the regulators get really hot and break free from the board, and that causes intermittent operation. Hint, hint, if you guys got a 780, pay attention to that. One of these days I'll go through going through one of those 780s. They cross my doorstep a lot. Okay, so all of that looks pretty good now. Given the proximity of the terminals, I will always scrape between the leads just to make sure I didn't accidentally have a solder bridge of some kind. That would be a bad day for us. Okay, let's go ahead and put the bottom cover back on. Okay, so this thing's pretty happy right now. We can go to another function. We can see that our channels, all the controls and everything work. Switches are nice and clean. FM works. You can see, my AM light came on after I cleaned the selector switch, so that's good. If you ever have to change the status lamps on one of these, it is a nightmare. You have to take the entire front panel off. There's a sub-assembly where the lamps are mounted into. You have to take loose and then carefully work that out while you take the old bulbs out and put the new ones in. They're 8-volt, 50 milliampere. Not a fun chore. So I think what I'm going to do is replace the dial lamps and call it a day, because this thing's otherwise done. Now, there's no bias or offset adjustments on these amplifiers. Everything is fixed. So assuming the amplifier is working well, you don't have to do a darn thing. The adjustment potentiometers that you see up here are for power output display. We can see that these are a little bit off, just the tiniest bit. And so what we can do is we can take an adjustment screwdriver, and for the left channel we can tweak it a little bit, assuming I can get one that actually fits. Just tweak that a little bit until they look more even. And of course, it's never going to be perfect. There's always going to be some discrepancy with these. That's pretty close, though. Everybody goes nuts when they don't track perfect. Problem is the ICs aren't perfect and they don't output perfect, so this is what you get. Okay, so to change the lamps on these, be very careful. Apply just the slightest amount of pressure to these release clips, just enough to get it loose, and then wiggle it out like that. The reason why, these are brittle as hell, and they will break. The more yellow looking and less white, the more brittle they are. And sometimes you just have to stick them in there with some putty while some glue dries. So the type of lamps that you need are a wedge style. You can get LEDs if you have to, but I just like the look of lamps better. They just pull out of the socket, but I need to put the camera down. And so that's what they look like there. You can get lamps from Duojo. Joseph Mirabella has LED kits that are really nice too. So let's just swap these out, put them back in. So there's our new lamps in there. And again, it's just the opposite of removal. You get one corner hooked first, and then very carefully pushed on the clip to get it in there. These things just break too easy. There we go. 8-volt, 300 milliampere if you're curious. So this thing's good to go. Let's see how much power it actually puts out here. Let me switch over to auxiliary. And then 10 volts per division should be good enough to display that. And let's go over to auxiliary, crank it up, and see where we start to clip. Right about there. And then we'll measure the voltage across the speaker terminals. In the case of that, that's 14.6 volts RMS. So what you do is you square that and then you divide by the resistive load, in this case 8 ohms. So if you're curious, that's about 26 watts per channel. Not bad. Good basic receiver for you. So this thing's all set. It's working quite nicely now. All the functions are operational. The tuner's aligned and works well. Meters and everything are happy. Yep, even the output calibration's good. Full output before clipping, you'd adjust the meter to read just below the final one, which is already in calibration, so that's good. So anyways, I hope you guys enjoyed this short video. More stuff to come.